Homework problem number 10 from section 6.1. We want to try and find a function for the curve above. So the functions that we look at look like something like this. Y equals some number times the sine, another number, x minus h in parentheses, and then plus k out here. And reminders about what each of these do. A here is going to give us the amplitude of the function. And that's the height off the midline. And then B here, that is going to tell us if this thing is horizontally stretched or compressed. So horizontal is either a stretch or a compression. And because of that, we're changing the period, how long it takes to make one cycle. And so we can find the period by taking what the period used to be of the normal sine or cosine 2 pi and dividing by whatever that number b is. So we can establish the period there. H is just a shift from where it started. So we also call that a phase shift. So that is a horizontal shift. Oops. Or phase shift. And K here is a vertical shift. And we call that the midline. And then we're given some specific points down here. So based on those points, we should be able to determine if any of the numbers A, B, H, or K changed from the typical. So typically, if we just think about the sine, there's no change in the amplitude. A is 1. There's no horizontal stretch or compression. B is 1. There's no shift left or right. H is 0. And there's no shift up or down. So K is also equal to 0. And then for the sine, we have a period of 2 pi. We have a midline of y equals 0. And we have an amplitude of 1, distance off the midline. So just what we're comparing to come up with this new equation here. So let's see, -9, -2. So we have that point there. And then 1, -2 here. So what I can see from here to here, bottom to bottom, is one complete cycle of the graph. So that's from -9 to 1. So that tells me the period, that's that distance. So that would be 1 minus -9, which is 10. Now, if I know the period, then I can figure out what the value b was there. So the period is always equal to 2 pi over b. And so cleaning this up, solving for b, we'll multiply the b over and divide the 10 down. 2 goes into 10 5 times. So then pi over 5 must be the multiplier to get this period here. So I know what b is. Other things to think about, what's the midline? So I look here, this bottoms out at y equals -2. It has a maximum of y equals +2. And so in between there, so if we take the minimum plus the maximum and divide by 2, that's going to give me the midline, right? Because the average value, what's in between the top and the bottom, add them up, divide by 2. So -2 plus +2 is 0, over 2 is still 0. So I know y equals 0 is the midline, oops, which is k. Now, since I know, let's draw that in, the midline is still the x-axis there, then I now know the amplitude. So the amplitude is just the distance off there. So the distance from there to there, that's going to be my amplitude. And so that looks like that's 2. So we're moving along here. So thinking about this function up here, I've identified what A is. Let's highlight that. Zoom, get out of the way. So we found A here. We found a value for B. We found a value for K. Next thing we need to do is think about a shift left or right. And there's a variety of ways to do that. And then they're going to give me some tips on it here. So let's see, read this more carefully. We got this curve, goes to those points. We want to find a sinusoidal curve that matches that. We can use pi as pi. Otherwise approximate to 2 decimal places. All right, I don't even think we're going to need to approximate. So the shift here, if we look at that, let's see, sine, this point right here is normally at the origin. So one way to look at it is that shift there. If we want to use the sine, if we want to use the cosine, the maximum is at the y-axis for the cosine. So we could say it's a shift there. So we could either use a sine or a cosine to do this. So maybe we'll try it both ways just for fun. So the shift for the sine function would be from here to there. And that looks to me like 3.5. Let's see. Yeah, I think that's about 3.5. Otherwise, if I think about the cosine, that would be a shift of 4. I'm going to try the shift of 3.5 there and see what happens. So I think one version of this equation, let's use red, and we'll graph it to check, would be y equals an amplitude of 2 times the sine. The horizontal stretch compression factor we calculated to be pi over 5. Parentheses for the shift. And that is a shift to the right of the normal sign. So I'm going to say that's a minus 3.5, close parentheses, and then plus 0. Who cares about plus 0? So I'm going to whip out a calculator and see if this gives me that graph with the 2 given points. We can actually plug the points in to check too. We could plug in 1, see what happens. Let's do that. We'll practice with sine arithmetic. So if x equals 1, I'm hoping we'll get -2 as the answer. So then y would be 2 times the sine of pi over 5 times 1 minus 3.5. 1 minus 3.5 would be -2.5. So then I would have pi times 5 over 5 times -2.5 inside here. And then 2.5 is half of 5. So that would clean up to be -pi over 2. So now I have twice the sine of -pi over 2. Thinking about the sine of -pi over 2, I like to go back to the unit circle if it's not a number I recognize immediately off the top of my head. So -pi over 2 would take me down here to this point. Sine is the y value, so sine should be equal to -1 there. So that means I'm going to get 2 times -1, which is -2, which is the correct y value. So this should be the right graph. But let's whip it out on the calculators to make sure. And I think I'll go with Desmos. No, I'm going to go with GeoGebra today. And then let's just use the graphing calculator. All right, so we think we got y equals twice the sine of pi over 5 times parentheses x minus 3.5. And GeoGebra puts my parentheses in there. And here I can see how I have that -9.2. I got the -4.2, which I also saw in the graph, and the 1.2, and there's my cross. So that looks like the right one. Just want to make a note that we didn't have to use the sine. We could have used the cosine to graph this. So let's look at how the cosine would work. If I wanted to use the cosine, I could use this point up here and think about a shift that way. And so that would be a shift to the left 4. So if I wanted to use cosine for this, I would say it would be y equals amplitude still 2. Period adjustment is still pi over 5. And then for the phase shift, I'm going to go left 4. So that would be an x plus 4. and we didn't shift it up or down. So I should get the exact same graph with this function right here. And that's both the blessing and the curse of trig functions. There's many ways to do the same thing. What's the best way? The one you come up with first, I guess. Pi over 5, x plus 4, and I can see that function is sitting right on top of the other function. Blue function is the cosine, green function is the sine. And are there other possible answers? The answer is yeah, there are. But those are two good ones. All right, well done.